Hi everyone, my name is Johannes Gilg from Technical University of Munich, and I'm going to give you a quick breakdown of our research described in the paper called "The Box Size Confidence Bias Harms Your Object Detector." Recent work has uncovered that the confidence prediction of object detectors are biased with regard to the bounding box size. We formally show that such a conditional confidence bias is non-optimal for object detectors' performance. Here's a quick illustration to understand why this is the case. In the reliability diagram, we have split our detections into two subgroups. These groups could be small and large bounding boxes. Now, if we calibrate the detector and condition on these two subgroups, we can see that detections with higher probability of being true positive detections have a higher confidence and vice versa. This brings the detector to a strictly better operating point in the position recall curve seen on the right. Now the question is, how large is this performance impact of the bounding box size confidence bias? If we simply use histogram binning for the calibration, we end up reducing the performance of the object detector. This has a variety of reasons that we address by modifying the standard histogram binning. We first use linear interpolation for the bins. Then we add bounds, adaptive bins, and weighting supports to deal with a non-uniform distribution of confidences. Here's an example of normal histogram binning and a modified version for 3 different bounding box sizes. You can see the linear splines and the smaller bootstrapped confidence intervals. Next, we have a look at different criteria we can use to choose the number of confidence bins and the number of box size bins for each object class. We found that our newly introduced heuristic to estimate the mean squared error of the true positive probability for each detection works quite well, and use it for our further experiments. Our research also found that the bounding box confidence bias is present in predictions on the training data. We use this to perform our debiasing exclusively on the training data, which allows us to fit the conditional calibration function using a large number of detections and prevents any information leakage from the validation set. Combining all of these steps, we can now estimate the performance impact of the bounding box bias on different object detectors. We applied our method to a range of different object detectors. Here are some of our findings. The performance impact varies from no impact to up to 0.6 medium average precision from the bounding box confidence bias. The impact tends to be stronger on smaller models. The impact is amplified by multi-scale test time augmentation, and on the two-stage object detectors we analyzed, there was no impact at all from the confidence bias. For more details, be sure to have a look at our paper.